Prior to this lesson, we've been working with trig functions and treating them and using them in right triangles, using them on the unit circle, and graphing them. In this lesson, we'll use them more as kind of objects to manipulate. And so in order to do that, we need to remember some of our basic trig identities. So, not going back to the definitions, but actually going to the relationship among each other. So, sine of x, you'll probably remember, is the reciprocal of one of our functions. Do you remember which one it is? If you said cosecant x, you're right. Sine of x is the reciprocal of cosecant, and we can write it like that. Also, if we have cosecant x, the reciprocal of cosecant is 1 over sine of x. If that's a little puzzling or something you feel like you have to memorize, play around with a number example first. Take 3/4. I'm sure you know the reciprocal of 3/4 is 4/3, but if you take 1 and divide it by 3/4, you'll see you end up with 4/3. Likewise, if you take 1 and divide it by 4/3, you'll end up with 3/4. Alright, time for cosine. Do you remember the reciprocal of cosine? If you said 1 over secant, you're correct. And similarly, if we have secant of x, it's the same as 1 over cosine. And the last reciprocal identity is with tangent. The reciprocal of tangent, you've got it, it's cotangent. And vice versa, the reciprocal of cotangent is 1 over tangent. So that means in this chapter, anytime we're working with sine, cosine, tangent, cosecant, secant, or cotangent, we can just replace that with what it's equal to. Or if we somewhere along the line end up with 1 over cosine x, we can replace it with secant x. Alright, there's two more that I need to talk about with tangent and cotangent. But first, let's go back to the unit circle for a minute. Remember on the unit circle, we said we've got a point on the unit circle, we'll call it xy. And we said that the x is this distance on the triangle and the y is the vertical distance to that point. And the radius is 1. So if that's the case, if we want to think about sine for just a minute, sine of my angle theta, we've been using the definition as y over r. But if my radius is 1, then that's y over 1 or just y. And if we look at that in the big picture, we can see that y is actually just equal to sine of theta on the unit circle. Similarly, we can do the same thing for cosine of theta. We know that's equal to x over r. On the unit circle, r is 1. So on the unit circle, x is the cosine of theta. Alright. If x is the cosine of theta, and y is the sine of theta, this gives a new definition for tangent and cotangent. If you remember, tangent has a definition of y over x. But if we look up here, we can think of y, on the unit circle of course, as sine theta over cosine theta. So this is another useful identity that we'll use often in this chapter, or this section. Anytime you see tangent of theta, it is also equal to sine theta over cosine theta. A quick side note, this ends up being true even if the radius isn't 1, because the radius divided by the radius cancels out. So if that's true for tangent, then you'll remember cotangent is equal to x over y. So we can think of that as cosine theta over sine theta. Quick side note, I'm a little sloppy with my variables. You could probably think of this as theta instead of x here. So, just a quick review. The basic trig identities you need to have at your fingertips are the reciprocal identities. So we've got sine, cosine, tangent, cosecant, secant, and cotangent, and their reciprocals. In addition, you need to be comfortable with these. The tangent is equal to sine theta over cosine theta, and cotangent of theta equals cosine theta over sine theta. Thank you.